Linear programming in 2 dimensions. Linear programming is a mathematical process that helps with decision making. So let's do application 1. A manufacturer of lightweight mountain tents makes a standard model and an expedition model. Each standard tents require 1 labor hour for cutting, 3 labor hours for assembly. The expedition tent requires 2 hours for cutting, 2 labor hours for cutting, and 4 labor hours for assembly. The maximum labor hours available per day for cutting is 32, and for assembly is 84, and this is respectively. If the company makes a profit of $50 for a standard tent and $80 for the expedition tent, how many tents should they make to minimize the total daily profit? So application problems can be overwhelming sometimes because you've got all this information going on and you may not need it all. So after you read through it once, you want to go to the underlying question. What is it asking for? It is asking for the maximized total daily profit. Now we're going to go back and we're going to pull parts out that we need. And you sometimes can draw pictures or graphs. I'm going to draw a chart, a table. And what I'm going to do is I know that I have a standard tent and I'm going to call it X. And I have an expedition tent and I'm going to call it Y. All right. So what's happening? We're talking about cutting department. And we're talking about assembly department. And then the next thing I noticed down here, we have a profit. They said that the standard has a $50 and then the expedition has an $80. Now let's go back to the second sentence here. And it says a standard tent's labor hours for cutting is 1. It says standard tent's labor hours for assembly is 3. This next one, this third one says expedition tents requires 2 labor hours for cutting and 4 labor hours for assembly. This fourth sentence says maximum labor hours available per day. So we have a maximum labor hours per day. And it says for the cutting is 32 and for the assembly is 84. So now that I have this in a format, now I'm able to write it in equation forms. So I'm gonna write the first one and I'm gonna call it C. That's my cutting. And it's going to be X times 1 plus 2 times Y. And it said maximum. So that means this cannot exceed this number. So I'm going to put less than or equal to. I'm going to call the assembly A. So I'm going to have 3 times X plus 4 times Y. And again, maximum. So I'm going to use less than or equal to the 84. That last one is our profit one. I'm going to call it capital P equals that $50 X plus $80 Y. Now I'm going to label, and I did this one part I didn't explain is I chose to let X represent the number of standard tents, and I chose to let Y represent the number of expedition tents. And usually I write that to the side somewhere, just so I have it and I know what I'm using it for. And this is the standard tents produced per day. And this is going to be, the Y is going to be the number of expedition tents per day to be produced, So, okay, moving on. So what I want to do is I want to graph A and C here and find where their corner point is. Now, if you have a graphing calculator, it's going to be much accurate, or a graphing sheet of paper with a ruler. That's going to be much more accurate than what I'm going to draw here on this table or on this paper here. So I'm going to find the x-intercept for C. Well, whenever I'm crossing the x-axis, I know y is 0, so I'm going to plug in 0. That leaves me if x is less than or equal to 32. So now I'm going to find the y-intercept for C. Whenever we cross the y-axis, x is 0. So I'm going to plug in 0 for x, and I get 2 is less than 2y is less than or equal to 32. Divide by the 2. Now I got y is less than or equal to 16. Then come over here and find A, and let's do the same thing. I'm going to plug in 0 for y to find the x-intercept. I'm left with 3. X is less than or equal to 84. Let's divide by 3. So that gives me x is less than or equal to 28. And now let's find its y-intercept. Oh, and let's write it in the order pair. I know x is 0. So when I plug in 0 for x, I'm left with 4y is less than or equal to 84. Divide by 4. Now y is less than or equal to, so 84 divided by 4, yeah, it's 21. Sometimes I just need to check myself. All right, so now I'm going to highlight these just right quick so I can graph them and I can see what I got on my paper. Sometimes you got so much going on, you just kind of overlook it, or at least I do. Not on purpose, but it happens. All right, so I've noticed I got 32, 12. Let's work in, I got to remember I don't have a whole lot of space on my paper. So I'm going to work in 10s. 10, 20, 30, 40. 10, 20, 30, 40. All right, so now let's do C. Its x-intercept is going to be 32. So it'd be somewhere right here. And then its y-intercept is going to be in somewhere about right here. And again, I strongly encourage you to use a ruler and a graphing paper or a graphing calculator. A is 28. So I'm going to go here and 21. About right here. Okay. It's not too bad. So what we need to do is figure out what part of the graph, because we're talking about inequalities, we still have to shade the part of the graph that's true. And if you will look, both equations says less than, right? So I know anything below it is going to be correct. And if you don't agree, just pick a point and put it in there. And if that side is less than the 32 and the 84, then you're good. All right, so now we got that done. The thing is, we need to know where they intersect at, because this is my corner point. And if you go to a graphing calculator, we're going to come out with 20, 6. So now that I know that, I got to pick the points that are actually closest to the section that gives us the accurate reading, meaning this y-intercept right here is closer to the area that's true. So that's the y-intercept I need to use for the next part. And I'm going to use my corner point, right, where they intersect at. And then this x-axis right here, we're going to use because it's the closest to the area that makes a true statement. So we are going to use 28, 0. So we need these 3 order pairs in order for us to figure out our profit. You can create a table for it. But let's go back to the question before we jump in the gun and get ahead of ourselves and do more work than we need. It just wants to know the maximize the total daily profit. So if we create a table and put all 3 of these on it to come up with a value, we can do that. And we have a profit of 50x plus 80y. So I'm going to plug in, well, x is 0 here, so I'm just going to have 80 times that 16. And when I multiply 80 times 16, I get 1280. Okay, now I got 20 for x plus 6 for y. So we get 1480. Now I got 28 for x and 0 for y. So we want to know the maximize. So I'm going to state that that's my maximize profit. My optical solution is going to be the 20, 6, and my maximize profit here would be 1480. All right, let's do the next one. And so I'm going to encourage you to pause this right now, read this information, kind of get a good grasp on it. Read this information right here, get a good grasp on it, and then let's move on and solve. I'm going to save some time and let's just jump in there and solve it. So what do we got here? We have a linear programming problem here where you're given a maximum equation right here, right? And then you're giving these equations here with two unknowns, and they have inequalities involved. So what I want to do is, first things first, let's get it graphed. Let's find where they intersect at. Let's find where their common area that agrees with the equation is, and then we can start solving for the main question here. All right. So I'm going to do my best to draw me a graph here. And let's come over here and find our intercepts. So we have x-intercepts. And whenever we solve for it, we know y is 0. And then we're going to have our y-intercepts. And whenever we solve for it, x is 0. All right, so let's do this. I'm going to label this A and I'm going to label this B. So for A, when I plug in 0 for y, I get 2x is less than or equal to 40. Divide by 2 because we want x to have a positive 1 coefficient. I get 20 for the answer. So I have order pair 20, 0. Over here, let's do A. Whenever I plug in 0 for x, I get y is less than or equal to 40. So that order pair is 0, 40. Now let's do B. Whenever I plug in 0 for y, I get x is less than or equal to 32. And whenever I plug in 0 for x, I get 2y is less than or equal to 32. Divide by 2. I get y is less than or equal to 16. So I have this order pair of 0, 16. I need to write my order pair here, 0, 32. Okay, so now that I have this, I'm going to, let me first things first, let's highlight my order pairs so I can see them when I go to graph them. Let's create our table of 10s. So we got 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. This is not going to be the most accurate. Again, you're going to want to use a graphing calculator or a graphing page with a ruler. All right, so first order pair, 20, 0. So we're going to mark it right here, 20, 0. The next one for A is going to be, remember this is A. The next one's going to be 40, 0. Or excuse me, 0, 40. It's going to be this one, or y-intercept. So I'm going to call it A. So I'm going to draw the best I can the lines together. All right, now let's do B. It's going to be 0, 32. So it should be about right here, and that line shouldn't have fell on it like it did, but my lines are not straight. And then it's, my apologies, guys, that was an x-intercept, so it should have been 32, 0. If you caught that, kudos to you. So it's going to be 32, 0. And then its y-intercept is 16, 0. Now let's draw that number line, and so they connect together. Now, here's the thing. The point right here is going to be our counterpoint. And we need this. So if you're using a graphing calculator or or you're drawing it out using a ruler and get it exact, you will see that that specific point right there where they intersect at is going to be 16, 8. So that's important. We need that. I'm going to erase that little circle. So my next thing is I need to determine where we're at on this graph as order pairs that are true to both equations. So it worked out nice and pretty. If you notice, they're both less thans, right? So I know that everything below the lines is going to be true. So I got to go below the lowest point right here. I can't go above it. Since I know this, what I'm going to have to do is pick this order pair and this order pair and this order pair to determine the next part, right? So what I'm going to do, and I also see that 0, 0 satisfies it, so I can use 0, 0 if I wanted to. So I'm going to create me a table. And I'm going to put in the order pairs. I'm going to go ahead and put 0, 0. You do not have to, but you can, because this statement here makes that statement, and it is a true statement. 0, 0 does give us true statements. Then I'm going to use the x-intercept that's closest to the area that's true, which is going to be 20, 0. I'm going to use the y-intercept that makes the statement true, or that's close to the area that we shade. So I get 0, 16. And then I want to use my corner point. All right. So I'm going to plug it in this formula here. P equals 10x plus 10y. And when I plug in 0, 0, I get 0. When I plug in 20 times 10, I get 200. And 0 times that y, or 0 going in the place of y, just gives me 0 there. If I plug in 0 in the place of x, I just get 0 there, and it leaves me with 10 times that 16, which is 160. This one here, I'm going to have 10 times 16 plus 10 times that 8. That's going to give me, double check my math on that, 240. And if we notice, this one here is my maximum, right? And so my statement would be my maximum value is 240, and it occurs when x equals 16 and y equals 8. All right, let's do the next one. So the next one says minimize and maximize. So we're given this equation here, and we're given the equations that with the inequalities and with the statement. So I notice all the inequalities are facing the same way. So this is going to make it a little bit easier for us. I'm going to still try to draw a straight line, graph me some points here. And so I want to do my x-intercepts, my y-intercepts. I want to plot this. I want to figure it out, find out where they meet and cross at, and what part of it's true and what order pairs I need to use. Okay, so let's do this. So I'm going to label this A, B, C. So for A, my x-intercept, we know we plug in 0 for y. that means I get 2x is greater than or equal to 24. Divide by that 2. X is greater than or equal to 12. So I'm going to put 12 in that order pair. Its y-intercept. We know x is 0. So I'm going to plug in 0 for x. I get y is greater than or equal to 24. And 24 is my answer. So now let's do B. The x-intercept, we're going to plug in y for 0 for y. And I get x is greater than or equal to 16. And then the y-intercept, we're going to plug in 0 for x. We get y is greater than or equal to 16. And then for C, x-intercept, we're going to plug in 0 for y. We get x is greater than or equal to 20. And then the y-intercept, we're going to plug in 0 for x. And we get 2y is greater than or equal to 20. Divide by 2, y is greater than or equal to 10. All right, so now I like to highlight just so I can see what I'm working with when I go to graph. And let's graph it. Let's do it in tens again. So 10, 20, 30, 40, 50, 60, 70. 10, 20, 30, 40, 50, 60, 70. All right. My A has a y-intercept of 12, so it's going to go right here. And, or excuse me, an x-intercept of 12 and a y-intercept of 24. Okay, and let's see if I can draw these dots together with a clean line. Ah, very good. All right, now let's do B. B has an x-intercept of 16 and a y-intercept of 16. Let's draw those two together. All right. C has an intercept of 20 for x and 10 for y. And let's draw those lines, those dots together. So we got a lot going on with these three lines. So, and it worked out nice and pretty since they're all greater than, then we know all this up here is going to be true for it. Okay. Since they're all going the same way, this makes life so much easier. We just know the shade up there. So our next thing is we got to see where they intersect at. You know, where then if you're looking at your graphing calculator, you're going to see two places that these lines actually intersect. And my graph is not the best looking, but they're going to have 2 points, 12, 4, and 8, 8. Now that I know this, I am going to go ahead and clean this up, and I'm going to make me a table. Let me make me a table here. All right. So let's use this one. All right. We have order pairs. And remember, we got to pick the intersections or the order pairs that are closest to where it is in the shaded area. So we have 0, 24, and then we have that 12, 4, and 8, 8. And we have 20, 0. Okay, and we're going to plug it into this equation given to us. And when I plug 0 in for x, I get 0, and now I got 60 times that 24. 60 times 24, we get 1440. Now I'm going to plug in 20 times 12 plus 60 times 4. And we'll get 480. we're gonna plug in 8. So I got 20 times 8 plus 60 times 8, 640. And then we got 20 times 20, which is 400. And 0 for y. All right, so now that we've done all this, we know that our maximum value here is 1440. So that's our maximum. And it occurs at 0.24. And our minimum value is 400, and it occurs at 20, 0. Okay, so now let's do example 4. It says a manufacturing company makes 2 types of water skis, a trick ski and a slalom ski. The relevant manufacturing data is given below. So you're given the table, so this makes it a little bit easier. We're going to call X the trick ski and Y the slalom ski. And now let's write this in a formula. So we know that 12X plus 10Y, and this says maximum. So that means this has to be less than or equal to 420. And then our next one is 1 times X plus 1 times Y less than or equal to 36. And A says that the profit for the trick skis is $60 and a profit for the slalom is 55. And we're going to write this in the formula. All right, so we want to know how many of each type of ski should manufacturer make each day to minimize or maximize the profit. So we're going to do this the same way. We're going to graph it, right? We're going to figure out what area is true for it and go from there. So I'm going to call this, let's call this this is fabricating, and this is finishing. Let's just call A and B because both of them starts with F. I didn't want to mess it up. So let's find A's intercept, x-intercept. So I plug in 0 for y, I get 12x is less than or equal to 420. We're going to divide by 12 on both sides. So 420 divided by 12 gives me 35. And then it's y-intercept, plug in 0 for x. And then we get 10y less than or equal to 420, which is divided by 10. Y is less than or equal to 42. All right, now let's do B. B, x-intercept. We get x is less than or equal to 36. 36 is it. The y-intercept, plug in 0 for x, we get y is less than or equal to 36. Okay, so now I can graph this. I'm going to put this on my graph here. And let's do it in 5s. 5, 10, 15, 20, 25, 30, 35, 40. 5, 10, 15, 20, 25, 30, 35, 40. All right. So on my A, I get an x-intercept and a y-intercept. So my x-intercept is 35, 0. So I'm going to go here, and then 42 for the y, right above that. Now let's connect our dots as straight line as we can. All right, then on B, let's do, we got 36. It's gonna be right past that, 35, and then our 36 for, so that one was 4240. We're gonna come down right here. And again, you're gonna get better, more accurate points if you use a graphing calculator. somewhere in here it crossed. So whenever you look at the graphing calculator, we're going to actually see that it's going to be 30,6. Also, we notice that these are both less than, they're both facing the same direction. So all the points below it, we're going to shade. Then that means we need to use the order pair that's closest to the shaded area. And that's going to be 0, 36, and 35, 0. And since we fell where 0, 0 is part of the order pair. Now let's go ahead and solve this. By plugging it in. So when I plug in so whenever we plug this in, we're going to plug it into our profit formula. So of course, when we plug in 0 for X and 0 for Y, we get 0. Now let's plug in 30 for X plus 6 for Y. We get 2130. Now we have 0 for X, so that goes away. So we have 55 times 36. And 55 times 36 is 1980. Now I have 35 times 60 gives me 2100. All right, so we want to know the maximized profit. As you can see here, the maximized profit is going to be 2130. So my statement would be the maximized profit value is 2,130, and it occurs at when X equals 30 and Y equals 6. Now let's go to part B. Part B says, well, what happens if the Solomsky decreases? If that price decreases? Well, let's change our profit formula. Now we're going to have 60X plus 40Y. And we're going to use the same order pair in our formula to determine what would be our maximum profit here. So again, let's use 0, 0. Let's use 0, 36. Let's use 30, 6, and 35, 0. So when we plug those points in, 0, 0 gives me 0. When we plug in 40 times that 36, we get 1440. When we plug in the 60 times 30 plus the 40 times 6, we get 2040. And then when we plug in 60 times 35, we get 2100. So now when we look at it, we see that when the profit on this, when the Solomskys decrease to $40, we have a maximum profit of 2100. And this occurs at 35, 0 when X equals 35 and Y equals 0. Okay, so now let's do the last one. The last one says, what if they increase the price on the Solemns? So now we got 60X plus 65Y. We're still going to use the same order pairs. we're gonna use, because we're still working with the same data. So that doesn't change. We don't want to change our data. All right. So now let's plug in. So when I plug in 0, 0, I get 0. When I plug in 0 for x, I get 0. I get 65 times 36 gives me 2340. I plug in 30 for x plus 6 for y. I get 2190. I plug in 35 for x and 0 for y. I get 2100. And now what do I have? My profit here. So the profit here on a solemn, when it increases to 2340, so $2,340, we have a maximum. So it increases to 2,340, and this maximum occurs when x equals 0 and y equals 36. And remember, the y represents the solemns and the x represents the Trixie. So if you were making a clean statement, you would actually make a statement of what that actually was. So let's do our last application problem here. So what do we got going on here? We have officers of a high school senior class are planning to rent buses and vans for a trip. Each bus can transport 60 students and it requires 3 chaperones, and it costs us $1,200. The van can transport 12 students, requires 1 chaperone, and it costs us $150 to rent. Since there are 900 students in the senior class that may be eligible to go on the trip, the officers must plan to accommodate at least 900 students. Since only 51 chaperones, 51 parents volunteered to chaperone, the officers must plan to use 51 chaperones. So we want to know how many vehicles that they rent in order to, and we want to minimize the transportation costs. So we want to know how many are we going to get and how to minimize the transportation costs. So what I'm going to do is I'm going to create my table. I got on my table, I have students, I have chaperones, and I have rental costs. Okay, so now I can separate my columns in X and Y's. I'm going to let X be my buses. I'm going to let my Y's be my van. And then my final column is going to be the number to accommodate. Okay, so let's fill in the blanks. So we have, what, 60 students and 3 chaperones, and it costs $1,200. So I said that wrong, guys. Please forgive me. So on the students, let's go back and highlight this. To transfer on the bus, we have 60 students. Okay, yes, we have 3 chaperones, but that goes down under by the chaperones. I wrote it by the van. Y'all catch that? And the rental is $1,200, and that goes here. All right, so now let's talk about the vans. When we look at the vans, it said that it can transport 12 students and 1 chaperone. So now I need to write 12 students, 1 chaperone, and it is $150 to rent. Now let's talk about the accommodation. On the students, it had at least 900 students. On the parents, the chaperones, we had at most 51. So now I have everything I need, and I can write this in formula method. So let's start with the first one. Our students formula is going to be 60x plus 12y is, and it said at least, so that means I can have more than that. So it's going to be greater than or equal to 900. My chaperones is going to be 3x plus y. And since it's at most, I'm going to set it less than or equal to because I cannot exceed that. And then now I have my cost formula. So C equals 1,200x plus 150y. So now what I'm going to do is I'm going to graph this. I'm going to find my area that best represents my equations to stand true and my corner points. So let's create our X and Y. So I'm going to call this the S and this one C. Let's find it. So my X intercept, we know that Y is 0. So let's plug in. I get 60x is greater than or equal to 900. Divide by 60. So I got 900 divided by 60. So now I got X is greater than or equal to 15. Now let's do the y-intercept. We know x is 0. So when I plug in 0 for x, I get 12y is greater than or equal to 900. I'm going to divide by 12. Now y is greater than or equal to 900 divided by 12. Is 75. Okay, so I'm going to clean this up a little bit so I can have some space down here. And let's do the next equation. All right, so now I have for the C, I'm going to plug in 0 for y. That gives me 3x is greater than or equal, or excuse me, is less than or equal to 51. Divide by 3. 3 goes into 51 17 times. So that order pair is 17, 0. And then when I come over here and find the y-intercept, I plug in 0 for x, I get y is less than or equal to 51. So now I got 0, 51. So I got my order pairs, and let's go ahead and graph this right here. And let's do this in tens. 10, 20, 30, 40, 50, 60, 70, 5. 10, 20, 30, 40, 50, 60, 70. 5. All right, now let's plot. The S has a x-intercept of 15, so it's going to be right here. And it has a y-intercept of 75. So, okay, 10, 20, 30, 40, 50, 60, 70. So right here. And I'm going to do my best to draw my line. It's not going to look accurate. Again, I would encourage you to use a graphing calculator. Now let's do the C. And the x-intercept is at 17, and the y-intercept is at 51. 1, 2, 3, 4, 5. So let's try to connect those dots. Now, what we're going to do is we're going to have to find the area that makes this true on this graph, and you really need a better way of reading it, because if you're reading it off my graph here, it's not a really good drawing. So I'm just going to read it off the graphing calculator. And what I noticed, they have a intersection of 12, 15. And now I'm going to check the area that's true for it. And when I do, I notice 1 is greater than, and the other one is less than. So it's going to be as simple as the other ones where I can say above or below. So we're actually going to have to look in between, like right here versus here. Which one of those is true? So what I'm going to do is pick points in between there to determine which one is true. And when I pick the point, let's see, let's pick in between the what do we got? 16. We can pick the order pair 16, 1. And when I pick it, I'm going to plug it into each one of those equations. So I got 60 times 16 plus 12 times 1. It's greater than or equal to 900. So I get 60 times 16 plus that 12. So I get 972. So I'm going to say it's true for that one because it is greater than 900. Let's plug it into the other one. So 3 times 16, well, that's 48 plus 1 is 49. It is less than 51. So true. So when I shade, I'm going to shade this area right here. What does that tell me? That tells me the order pair that I'm going to use to get my final answer. It's going to be these Y or x-intercepts because they're the ones that's in the area that makes a true statement for these inequalities. So let's do this. Let's create our table. So I got order pair 15, 0, 12, 15, and 17, 0. And we're going to plug it into our cost formula. And when we plug it in, I get 1,200 times 15. So I get 18,000. I'm going to plug this in here. And I get 16,650. And then let's plug in the 17. And we get 2,400. So now my answer here is my minimize, right? The minimum amount, that's what it asks for, is going to be the minimize the transportation cost should be, when you rent it, 12 buses and 15 vans. And they have minimized the cost, the transportation cost, to $16,650.